Good day, students. Today we're going to look at a solution to a problem involving the Pythagorean theorem, a very common theorem which you need to know, and it's number 4D on page 20 of chapter 6, which is in book 3 of your ma1026 booklets. Now I'm drawing a triangle there on the side just to review or recall the Pythagorean theorem. Of course, the right angle would be here, and it would be marked with a little indicator like that, and the side opposite the right angle is always called the hypotenuse. I'll abbreviate that HYP. Okay, HYP. And the other two are called legs. This is a leg and this is a leg. And what the Pythagorean theorem says, if you add both legs together and square them, you will get the length of the hypotenuse squared. Okay, so the hypotenuse squared equals both legs squared and added together. Okay, so and they use the letters. The most common letters used are, of course, A and B for legs and C for hypotenuse. So you've seen it written as C squared equals A squared plus B squared. Or you've seen the C squared on the other side. It's written as A squared plus B squared equals C squared. But the trick to remembering this is just to remember, if you're finding a hypotenuse, okay, you're going to add the sum of the squares of the other two sides, the legs. Okay, so if you're finding a hypotenuse, add the legs. If you actually want to find the leg of a triangle, then of course you're going to subtract from the hypotenuse. So it's the hypotenuse squared minus the other leg squared. Okay, so one way of memorizing it, if you're looking for the hypotenuse, add. Okay, if you're looking for a leg, then you're going to subtract the larger side, the hypotenuse, from, or the smaller side from the larger side. Okay, so there's different ways to memorize it. I'm sure you have your own technique of memorizing that, whatever you prefer. Okay, but this problem here involves the Pythagorean theorem. Now we're given three right triangles. I hope you can see all three of them there. Right, the first one has a right angle here, so that would make PQS a right triangle. Then of course, if that's a right angle, this is a right angle, which would make the smaller one, right, a right triangle as well, SQR. And because of this angle up here, the large one is also a right triangle. So we have different options in calculating the lengths of the sides. And sometimes it helps for some people to separate. Okay, for example, if I'm just looking at finding X, right, you probably see I'm going to use this triangle here. Okay, so, and if I'm going to do that, you know, you may want to separate it and draw it again, but it's up to you. You don't have to do this. So I'll do a rough sketch here. You can see now I'm drawing triangle SQR with a right angle here at angle Q. Of course, this makes SR the hypotenuse, which is 8. One of the legs, QR, is 4. How do we find the other leg? Okay, and again they have that leg called X, so let's put that in there. So if you understand what I just did, you'll know that we're looking for a leg. Therefore X squared is equal to the hypotenuse squared subtract the other leg squared. And then of course it's a matter of just doing your numbers correctly. 8 squared of course is 64. 4 squared of course is 16, and 64 subtract 16 is 48. So it's almost 7 if you get the square root of that. Okay, so X is equal to the square root of 48, which of course is, we know it's going to be very close to 7, 6.93. Now in the instructions, I'm just checking here to see if we were told to, oh, it said round your answer to 1 decimal place, so therefore always check your instructions to see Alright, so the answer is 6.9 for x. 6.9. Alright, now you have a couple of ways you can find y. I don't know, you could use x and use the smaller right triangle, PSQ. You could do it that way, right? Or you can use the large right triangle, which I think I'll choose to do. I'm just going to redraw the large right triangle. Larger one, this looks something like this. This is 8. This is y. Now how much is this side here? Can you see? PR. This is PSR. How much is PR? Well, if you look at this, we're looking for the length of PR. We got 12 as PQ and 4 as QR. So you have to add 2 of those. So this side will be 12 plus 4, right? So this side is 16. Now this is one way you could do it. You could also do it using the value x. There's another way you can do that. And now when we tackle this problem, let's see what we get. What are we looking for this time? Well, remember, what is this one? It's opposite the right angle. If you're still not sure, yes, it's the hypotenuse. Okay? Remember, when you want the hypotenuse squared is equal to the other 2 legs squared and added together. So we're adding when we get the hypotenuse. Okay? Are we looking for the hypotenuse though? No, we're looking for a leg. Therefore, we need to do what? We need to subtract. That's correct. Excellent. So we bring that over. So that's why we always check and make sure we had that set up correctly first. Okay? Let me just take that away. It's a little messy there. So again, I'm sure you have this memorized using A, B, C, or other letters or your own format. Okay? So we're looking for the leg, y. Right? Let me just get rid of that now. So let's go back. So here's the leg we're looking for. This is a leg, and this is a leg. Right? So y squared equals 16 squared minus 8 squared. Correct. So the hypotenuse. So that's one way to do it. 16 squared, of course, is 256. So you can just put that all in your calculator if you want to do it that way. 8 squared is 64. 256 subtract 64 is what? Let me double check. 192. That's correct. That's y squared. Now y is the square root of that. Okay, and the square root of 192 is 13.856. And of course I'm going to round that off to 1 decimal place. That's going to be 13.9 units. Okay, so y is 13.9. X is down here. X was equal to 6.9. And any other variables to solve for? Nope, that looks like it. X and y. So that's the solution to number 4D on page 20.